Okay, so question 6. What is the Lewis structure? Oxygen difluoride. So let's first find the total valence electrons in the molecule. So the oxygen atom contains 6 valence electrons, and a fluorine atom contains 7, and there are 2 of them. So 14 plus 6 is 20. So now I'll draw my central atom, which is the oxygen, and the fluorines as the 2 terminal atoms. And I'll show all of the lone pairs. So fluorine has 3 lone pairs. And notice that oxygen doesn't have a full octet yet, and we've only drawn 16 electrons so far. So we need 4 more, so I'm just going to draw them in the form of lone pairs on the oxygen atom. So we can draw this showing how the molecule is like bent. And this is the Lewis structure for oxygen difluoride. And the junior tutor said that Lewis dot structure is a representation of an atom, ion, or compound that shows how the valence electrons of the atoms are distributed as bonds, lone pairs, and sometimes radicals. The octet rule can be used as a guideline in many but not all cases, and in drawing the Lewis structures. This rule states that the atom desires to have 8 valence electrons. This can be done via accepting, donating, or sharing electrons. We can apply the octet rule to the atoms in OF2 to determine the molecule's Lewis structure. Oxygen has 6, and therefore to achieve the octet state, it may create 2 covalent bonds. This would require 2 of its valence electrons, so the remaining 4 electrons will be represented as 2 lone pairs. On the other hand, fluorine has 7, thus it needs 1 bond only, and the remaining 6 electrons will be drawn as 3 lone pairs. Based on these, the 2 fluorine atoms must be singly bonded to the oxygen. This way, all atoms achieve the much desired octet state. Thus, the Lewis structure is... Yep. So, this solution is correct.